All right, welcome to Trig. This is the Law of Sine. So we're going to start with a little bit of the proof of it. So you don't have to write down the proof, but I wanted you to see it so that it'll help you remember the formula. So we're going to start with a triangle, and it could be any type of triangle. It does not have to be a right triangle. Actually, it's probably better if it's not. And then we're just going to label it. So we label each of the angles with capital letters. So we labeled capital A, capital C, and capital B. And then across from them, we're going to label the sides with a lowercase of the same letter. So across from capital A is little a, and across from capital B is your little b, and then across from capital C is your little lowercase c. So we just label it, and it can be any triangle. Then we're going to drop an altitude. So this altitude gives us the right triangle we always want. And we're just going to label it with just an H for height. And we're going to set up, now that I have a right triangle, I can set up my sines, my sine equations. So if we do sine of capital A, sine, remember, is opposite over hypotenuse. So the opposite would be our H. Our hypotenuse would be that little b. So remember, opposite over hypotenuse. Similarly, I can write the sine of b. So if I go sine of capital B, sine of capital B would be, again, opposite. So H over hypotenuse, which in that case, because that's this triangle over here. So then my opposite is H, and my hypotenuse is A. So I'm going to put an A right there. Now, I want to get rid of the H because that's not in my original equation. So I'm going to solve both of those for H. So multiplying the B over in the top equation. So this one's going to give us B sine of capital A equaling H. And then the second one is going to give us A sine of capital B equaling H. And now that I know that both of those are equal to H, I can set them equal to each other. So I know that little b times sine of capital A equals A sine of capital B, which gives me a relationship. And what I'm actually going to do is I'm going to divide off those constants back across. So I'm going to divide by the B and the A. So I'm dividing both sides by B and A, canceling those, and it's giving me this relationship of sine of capital A over little a equaling sine of capital B over little b. Now, the labeling of those sides, it didn't matter which one I called them. I could have called them any variables I wanted. And so we can get an actual law of sines, which is the relationship of all of them. And it is the sine of any angle across from its side equals the sine of a different angle on the same triangle divided by its opposite side. And that still equals even the third side. So you can set up any common setup of this, any piece of that. And you can even flip this around and do the lowercase letters on the top. So we could write it, if we prefer, as little a over sine of capital A equals little b over sine of capital B, or little c over sine of capital C. So it can go in either direction. So this is called the law of sines, and you'll use pieces of it. You don't use all of it at once. So you might use the first two, or you might use the second two, or you might use the first and the last, because they're all equal to each other. So you just use any two and solve for the missing pieces. Now, this works for triangles that aren't necessarily right. So that's kind of the good news of it, is you don't have to have a right triangle. What you do need is you need three pieces. So you need either one side and two angles, or you need two sides and the angle that's not in between, not included. So that means you need to have a pairing of the same letters. So you need to either have both A's or both B's or both C's, something of that sort. All right, so let's put this into practice. So let's say I have a triangle where A is 32 degrees, B is 81 degrees, and then little a we'll say is 43 centimeters. All right, so with something like this, you need to have 3 pieces, obviously. I need to make sure that I have 1 pair of matching. So I do in this case, I'm good. I've got both the capital A and the lowercase a. So I'm definitely going to use a formula that has both A's in it. So, and then I want to put whatever I'm looking for up on the top. So what are the missing pieces? So I'm missing capital C, I'm missing little b, and I'm missing little c. So it's good to identify what it is I need to find. Now, capital C I can find right away because I know all angles add up to 180 in a triangle. So all angles in a triangle sum to 180. So if I know 2 of them, I can find the third. So I can take 180 minus 32 and minus 81. And let's see. So that's 180 minus 113, which gives me 67 for C. So that's going to go right there. All right. Then for little b and little c, I'm going to have to use the law of sines. So for little b, I'm looking for little b, so I'm going to put that first and on top because that's who I'm looking for. And under it, I go sine of capital B, which is sine of 81. And then with it, I'm going to use little a, so that's the 43 over sine of 32. So I plug all of that in. So let's highlight, make sure you see where all the pieces come from. The 81 is here. Those 2 are the A's. Okay. Now we're going to multiply up the sine of 81. And you can actually change these all into numbers if you'd like. So I've got B equals sine of 81 multiplied by my 43 over sine of 32. I'm going to use, definitely going to want a calculator for this. You can also use Desmos if you're wanting, if you don't have a calculator that you're comfortable with. So I'm going to type all of that in, and I get 80.1. Well, let's round that to 80 centimeters. All right, so that's going to come back up to here. All right, so once I have that, then I can find, I cannot use Pythagorean's theorem because that doesn't really hold, but I can set up the same thing but use C. So I'm going C over sine of C, which our C is 67, equals that same A, sine of 43 over sine of 32. Okay. So I've got, let's see, these are still my A's. And then my 67 is that C. So we're going to use it to find our lowercase c. So again, I'm going to multiply up sine of 67 times my 43 sine of 32. Plug it all in. And we get 74.7, so let's go 75 centimeters. And that's my C. So now I have all of the pieces. So that is an example of when you're given 2 of the angles and you need to find the third angle by using the angle sum theorem. And then you set up the fractions from Law of Sines to find the other missing sides. Okay, let's go All right, so now what happens if we have the other possibility, which is if I give you one angle. So we'll start with an A. We'll say that A is 70, let's do 74 degrees. And then little b, or little c, let's do little c, is 859 meters. And we'll say little a is 783 meters. Okay, so this time I'm given one angle and two sides. So I don't have enough of the angles to find the angles, because I need at least one more. I do have a pairing. This is super important that you have an A and an A. So we have to have a pair that we can set up. And I don't have anything with B, so I can't find little b yet until I find angle B. So I need to find the angles first. So let's start with finding angle C, since I have little c. And since I'm looking for the angle, I'm going to put the signs on top. So I'm going to sine of C over your little c equals sine of 74 over 783 for little a. So the a's go together, the c's go together. Now I can again multiply up. So this is sine of C equals 859 times the sine of 74 over 783. All right, again, I'm going to go to the calculator on this. So 859 divided by 783. All right, so I get sine of C equals 1.05. Now that is not my angle C. That's what sine equals. So to find C, I have to do the inverse. So remember our inverse that we worked on last chapter? So we're going to go inverse sine of that value. And you can use inverse sine on your calculator. It's usually with your sine button. Now you're going to have one problem on this one, because I'm hoping some of you noticed it, that there's going to be a domain error, because can sine ever be larger than 1? And the answer is no. So in this case, there is no solution. And so we have actually a problem here, is that this doesn't make a triangle. So these two sides with this angle cannot make a triangle. So you're just going to stop in this case. So with this, we get into what's called the ambiguous case. So sometimes you're going to have answers and sometimes you're not. So when you are looking, so the ambiguous case, let's write this out. Case, the ambiguous case is when you have two sides and an angle. So side angle from geometry. That when you have the side angle, looking for angles, then you actually have multiple things that could happen. You could have three options. You could have no triangle, like we just saw. Come on. You could have one triangle. You actually could also have two triangles. So you have different things that could happen, and it's kind of based off of where things hit. So as you draw it, you can have different pieces that come apart. Let's see. Do I have one that comes? Do we have? Yep. Okay. So let's do one last example. We've got capital B. Come on, capital B. Equal to 56 degrees. Little a is 8.3. And little b is 7.6. All right, so on this, I'm looking for capital A, capital C, and little c. Those are the three things I'm looking for. I have a pairing, which is always super important. I need to have matching B's. or matching some letter. So in this case, I have matching B's. So those two are going to go together. And since I have part of A, I'm going to start by finding the rest of A. So I'm going to finish out that partnership. So I'm going to be looking for capital A. So I put sine of A over little a, which is 8.3. And that equals the one I have a partner for. So sine of 56 over the 7.6. All right, so we multiply. So sine of A equals 8.3 sine of 56 over 7.6. So plug that in. Oh. All right, so we get sine of A equals 0.9, which is good. So this actually has now two options. So this is where we get into the ambiguous case. We're going to do the inverse sine of that number. And we get 65 degrees. So that is one option. Now notice that is in the first quadrant. But if you remember your triangle or your circle, that sine is positive here and it's positive over here. So we could also have a second quadrant answer. So we're going to take, for the other one, we're going to take 180 minus our 65 as if we are coming back up into that second quadrant. And we get 115. That is our second possible A. So we have two cases now. So up here, one option is 65, but the other option is 115. So I actually have 65, but I also could have capital A equaling 115. Now, once I have a second capital A, I also have a second capital C and a second lowercase c. So to find the C's, remember that we want to take 180 minus because they're the triangle sum theorem. So we're going to take 180 minus our 56 and minus our 65. That gives me one answer. Or the other one is 180 minus the 56 minus the 115. So we've got two ones that we're checking. Minus 56 minus 65. We get 59 in that case, so that's 59 here. Now the other one, we get 9. Okay, so we have our two different choices. So let's see. Those both come from our C. And so with both of those, then we can set up the other way and solve for little c also. So then you can set up and solve for little c using your, let's use B, so 7.6 over sine of 56 equals little c over sine of capital C. And you're going to do this twice. You're going to plug in once with your 59 and once with your 9. And so 7.6 divided by sine of 56 times sine of, let's do the 59 first. So that gives us 7.9. And then you could do it similarly down here, but the next time, instead of using 56, or keep the 56, but instead of using the 59, we're just going to use the 9 degrees. And that gives me 1.4. All right, so now I have two sets of answers. So this is an example of the two triangles. And the example of the one triangle would be is if you went to solve for the second angle,